In this video, we're going to try and work out the area underneath a parametric curve. So let me show you by giving you an example. So we are going to try and work out the area underneath these parametric equations, t being from 0 all the way to 4. So you wanting to find out this area is really you wanting to sum up all the rectangles. So you wanting to find out the area, it's really you wanting to sum up all the rectangles. So if you look at this random rectangle here, the thickness associated with this rectangle would be dx. But you wanting to sum up all the rectangles, well, each step of the way, you're going to need to know the height. You need to know the height. Well, the height is given by y. So the whole area here is given by this. But when it comes to parametric equations, we are working in terms of time. So it is the time that drives everything. We want to integrate it from time being from 0 to 4. So us working in parametric terms would be us working in terms of time. This is in terms of time. Earlier, the area was really us working in terms of y and dx here. So we wanting to find the area from time 0 to time 4. What that means is, in terms of x and y, we are integrating from -4 all the way to, well, if you want to know this, it would be you doing this. Well, time all the way to 4 would be, if you want to find out this, it's really you doing this. Put the 4 into here. That would give you 16. Take away 4 would be 12. So this thing here would be 12. Remember, we are integrating with respect to time. In this case here, we are integrating with respect to dx. But because we're working with parametric equations, we have to abandon this and work in terms of dt. So in terms of dt, it would be us doing this. We want to know the area. Well, the area is really us summing up all the rectangles here. So let's look at this random rectangle here. The height here, we're going to need to know the height each step of the way. Well, the height is given by this. It would be given by t. And then so when we're working with parametric equations, we are working in terms of time. Remember, we are integrating from time 0 to time 4. Well, the thickness, let's say a small change in time here between here and here, a small change in time, let's say this is dt. A small change in time would result in a small change in the thickness of this rectangle. Well, if there's a small change in time, what would be the thickness of this dx? What would be the thickness of this dx? Because when we're working with parametric equations, we are working in terms of time. So a small change in time would result in a small change in the thickness of this rectangle. We need to work out this thickness here. Well, to work out this thickness, we would use this. So at the moment we've got x equals this thing. If you want to know a small change in that thickness, a small change in this, so a small change in time here, hang on, bear with me. So a small change in time from here to here, it would be dt. But then this dt, a small change in time, would result in a small change in dx. But what is this small change in dx? Well, look at this here. At the moment, it's x equals this thing. If you differentiate both sides, it would be dx equals, differentiate this would be 2t dt. You see, a small change in dt, and when you combine it with this, it will give you a small change in dx. So if you want to find out the area, if you want to find out the area in terms of time, it would be you summing up everything. So remember, it's you summing up all the rectangles here. We are always going to need the height each step of the way. Well, the height is t. But then we would need to know the associated thickness of this. But because we're working in terms of dt, a small change in time, well, a small change in time would be, hang on, bear with me, a small change in time looking at this here, it would be 2t dt. So a small change in time, combine it with this, and that will then give you this thickness here. So put this into here. So it will be times 2t dt. And because we're integrating with respect to time, it's nice and simple. It's just simply 0 to 4. So the area would be given by us evaluating this. So the area is really us evaluating this. So now the rest is simple. The rest is simple. So integrate it, blah blah blah. The area will be given by this. Okay.